Vanakkam. Welcome to this course on classics in neuroscience. From this video onwards, we will start looking at cortical columns and cortical processing. These are also neural circuits. Remember, in the previous set of videos, we looked at neural circuits, excitation and inhibition that happens within the spinal cord, excitation and inhibition that happen within retina, for example, and examples of invertebrate systems and spinal or central pattern generators. This is what we looked at the previous set of videos. From this video, we start moving a little bit up, and we go to the cortex, the cerebral cortex, and we look at cortical columns and how cortical processing happens. In this video, we introduce the concept or the notion of cortical column, and we discuss the work of Raphael Laurent Deneau. Remember, the 1950s were the golden age of discovery in cerebral cortex. It is a golden age of discovery in many regions of the central nervous system, and there were many neural circuits that were discovered or uncovered in the 1950s, but also in the cerebral cortex. The earlier discussions were on the spinal cord, the connections within the spinal cord or the neural circuitry within the spinal cord were discussed at some depth. Similar organization, can we find a similar organization within the cerebral cortex? That is the question. So, people used microelectrode recordings to study cortical systems, and it was believed, it was proposed that cortical columns were the organizing principles, that neurons and neuronal circuitry within the cortex were organized as columns. That is, there was one central afferent neuron, and there were radial neurons that were surrounding this central neuron in many layers. It was also suggested there was the presence of the homunculus or the map of the body, the little man within the brain. This was shown to be present in the somatosensory cortex. This was shown to be present in the motor cortex. Later, this was also demonstrated, not one, but more than one homunculus was also shown to be present in the cerebellum. That is later. Of course, visual cortex, visual stimuli and feature detectors and frequency mapping was also found. So, that kind of map was found, and frequency map in the auditory cortex was found. And within the motor cortex, it was seen that there was excitation and inhibition, lateral excitation and inhibition within the motor cortex or motor homunculus, and representation of odors by spatial activation patterns as somewhat similar to what we saw in the surround inhibition, surround excitation concept in the retina, is also seen, for example, in the olfactory bulb. These are all the various forms of organization within the cortex. So, there are many different systems, sensory systems, visual cortex, auditory cortex, olfactory bulb, motor cortex, in motor system, the motor cortex, then there is the big somatosensory system. So, all these have some organizations. Of course, the cerebellum discussion is outside the cortex, obviously outside the cerebral cortex, but just mentioned about the little man. Because we discussed about the little man, I mentioned that this is also seen in other nuclei, other systems. Raphael Laurent Deneau was a former student of none other than Santiago Ramon y Cajal. And in 1938, he was invited by Fulton to author an article about the organization of the cortex. in the neurophysiology book, Physiology of the Nervous System by Fulton. In that, Laurent Deneau was invited to contribute a chapter. In that chapter, he provided a masterly account of the organization of the cerebral cortex, but he also formulated a new hypothesis for cortical function. So, he also formulated a entirely new hypothesis for cortical function, which he says, I am going to read from the original text. Save for layers 1 and 2, all cortical layers contain cells having synaptic contacts with specific afferents, so that it would be improper to call any one layer as a receptor. Also, on the other hand, every layer except layer 1 has axons reaching the white matter, and therefore, no layer may be called as an effector. So this means that it is not a simple input output system that is comparable to the spinal cord. The information processing that happens in the cortex is a lot more complicated, that is clear. So, no single layer may be called as a receptor and no single layer may be called as a effector. That means that there is connections between that go and happen between various layers. But how do intrinsic connections happen? That is the question. Laurent Deneau proposed that these happen within vertical cylinders of cells. That is, what are these intrinsic connections? These are connections that happen within a layer, and these are also connections that happen between layers. But he suggested that this happens within vertical cylinders of cells, suggesting that this cylinder is a column, and this is a radial cylinder with an input output unit that is somewhat comparable to the elementary spinal reflex unit, but the comparison is only somewhat, right. Because why is this? Because the information processing environment of the cerebral cortex is a lot more complicated than the information processing environment of the spinal cord, that is why. So, another critical point to understanding and visualizing Laurent Deneau's concept was that there were loops or connections that happen within the radial unit that excite each other, that could set up reverberating circuits that could keep on exciting each other for a relatively long period of time. These kind of circuits are believed to play a critical role in the formation and preservation of short term and long term memory. So, these are later shown by work done by, for example, Hebb and others, which we will discuss in future chapters. But these kind of reverberating circuits are not that uncommon in the brain. There are many levels at which reverberating circuits happen, then there are many nuclei within which or between which reverberating circuits are present, and there is a purpose to this. It is not like they are simply exciting each other, there is a reason why they exist. Many times there is a functional significance for this. So, these connections within the radial loops can form loops or reverberating circuits that can keep excitation going between each other for a relatively long period of time. So, what do we mean by long period of time? Several minutes, for example, is considered a long period of time in the context of neuroscience, or hours is an extremely long period of time in the context of neuroscience. Millimeters and centimeters an extremely long distance in the context of neuroscience. Just letting you know, in case you are new students of neuroscience, this is what we mean. Long period of time means several hours is an extremely long period of time in neuroscience. So, these kind of reverberating circuits later formed the basis for learning and memory, short term learning, short term memory, long term learning and memory, that we later discuss in later chapters. With this, we come to the end of this video. In this video, we looked at the cortical column, the concept of the cortical column, and how organization of neurons or neuronal organization happens around a central vertical cylinder, and neurons connect to this central neuron, and the contribution of Raphael Laurent Dino towards conceptualizing and visualizing this crucial concept of functional organization within the cerebral cortex. Thank you very much for your attention.